The name of this lesson is prime factors. What do you guys think that means? What's the word factor mean? Numbers that multiply to give you a number, right? So what would prime factors be? They would be the prime numbers that go into a number, okay? So for example, let's do 21. We know that 21 is equal to 7 times 3. So it has two prime factors, 7 and 3, okay? So there's a quick example before we get into some specific examples. And yes, for this lesson, you need to keep factoring, okay? Yesterday we just factored, right? We got two factors and then we did different pairs, but we didn't factor it anymore. We didn't make a tree. Today we're making a tree. Make sure you write this definition down for prime factors. All of the factors of a number that are prime numbers. That's what prime factors are. We will be using prime factors to find the greatest common factor of two numbers and the least common multiple. You can find both of those using prime factorization. So let's take a look at example 1. It says find all the prime factors of 30. Okay, so make sure you write these steps down. You only have to write them down once. Step 1 is to factor. And guess what? There's more than one way to do this. There's a lot of different ways to make a prime factor tree. I will say this though. Usually it's better if you find two numbers that are close to each other. So what are two numbers that are close to each other that multiply to give you 30? 5 and 6. Now, like I said, okay, you can do 2 times 15, and your final answer is going to be the same as the person next to you, okay? Okay, so now that we've done that, what does step 2 say? It says factor all the way, so we need to keep drawing our tree. Okay, now 5 really can't be factored anymore, so we'll just do itself in 1, okay?
Your teacher made me do this in 5th grade.
How about 6? Okay, in fact, what we should probably do with the 5, actually, we don't want to write 1 because 1 is not a prime. What we're going to do with the 5 is just drop it down. That way we have our answers next to each other. So, is 5 a prime number? Is 3 a prime number? Is 2 a prime number? So once all of your bottom numbers are primes, then we can say that we factored all the way. If not all the bottom numbers are primes, you have not factored all the way. You need to keep going, okay? If we had, let's say we had a 9 on the bottom, we need to break that down to 3 times 3, okay? Otherwise, just drop the number down. Step 3, go ahead and write your answer out. And what I mean by that is, let's write the original number, 30, equal to its prime factors, 5 times 3, times 3 times 2. So this is our final answer. And when I give you the worksheet, you need to make sure and show your work exactly the same way. That would be the prime factorization. I think it's easy, right? Yes.
My teacher, like, to get us ready to do this, she has put on one paper and stuff factors from 1 to 100.
Okay, that works. You can do a factor. You can do a example 2. We want to find the prime factors of 54. Again, if you can find two numbers that are close to each other, it's going to make the process simpler. Now we can do 2 and 27. Can you think of any two other numbers? 9. 9 and 6. See how those are closer to each other than 2 and 27? So what will end up happening is you'll end up at your answer quicker, I believe, by choosing two numbers closer to each other. Okay, are we done, or do we need to factor some more? Good, because neither 9 or 6 are prime. So what goes into 9?
3 and 3. And then 2 and, yeah.
So now we have 3, 3, 3, and 2. Are all those prime factors? Yes. So that's how we know we're done. So final answer for this one, 54 is equal to 3 times 3. And in case you didn't notice, yeah, I see that. In case you didn't notice, yes, you can have multiple factors the same. In other words, here we have 3 3s, and that's okay. You could have 4 3s, right? 3 times 3 times 3 times 3 is 81. That would be the prime factorization of 81. Yes, write that down. What he's saying is, you can also write this as 54 times, 54 equals 3 to the third power, because that's how many 3's there are, times 2. I like that observation. Thank you for that. Number 3, I kind of just gave this one away. So what are two numbers close to each other that multiply to give you 89? 9 and 9. In fact, they're exactly the same number. Okay? Now we need to factor all the way, so we're going to break this down again into what? Are all these numbers on the bottom prime? Yes. So final answer, 81 equals, yeah. So we can write 3 times 3 times 3 times 3, or we can write 81 equals 3 to the 4th. So let's do one on the worksheet that had a lot of factors in it. 120. Again, let's try to find two numbers closest to each other. How about 12 and 10? I can't think of any two numbers closer that give you 120, okay? Again, you could do 30 and 4 and you're going to get the same answer as everybody else. Okay, now we know both of these are not prime, so we need to break them down again. What does 12 break down to?
6 and 2.
Okay, 6 and 2, or let's try two numbers closer, 4 and 3. Okay, and then 10, got to be 5 and 2, right? Now that's good for 10, 5 and 2 are both prime, so we can stop there. But we still need to factor the 4 down to what?
2 and 2.
Okay, so again, every other number, just make sure that you drop it down. Now here we see that we've got 2, 2, and 2 here, so you could write that as 2 cubed even though they're not next to each other. That's because the order in which you multiply numbers does not matter. Final answer, 120 equals, we'll go ahead and write it your guys' way, 2 cubed times 3 times 5. Or you could just write it this way, same thing. Examples, 210. Okay, so can you think of two numbers close to each other that multiply to give you 210? Not 30 and 7, right? Those are far apart. 21 and 10, I think that's the closest.
105 and 2.
105 and 2, okay. Okay, so we'll do, what did we just say? 21 and 10. Okay, next we're going to break up the 21 into what? 7 and 3. And fortunately, those are prime, and also 5 and 2 are prime. So after just 2 steps, we're done with this one. 2, 3, 5, and 7. Final answer, 210 is equal to 7, and we can do it from biggest to smallest, it doesn't matter, times 3 times 2. 7 times 5 times 3 times 2. I think every number on the worksheet is less than 200. Final one. 101.
Isn't that one?
Yep, it's prime itself, so actually it only, remember 1's not really a prime number, so if you think about this one, the only prime factor is itself. Whoops. You could put itself, yes. 101 is the only prime factor of 101. And that's it.